In this video, we will show you the settings for using the Spectran V6 Eco as a signal generator in TX mode. In the block editor, you can see the available blocks. The V6 Eco has already been detected and placed into the Edit window. To use the Eco as a signal generator, you first need to enable TX mode in the device manager. In this example, we are working with a 150 model. The signal generator feature is not available on the 100 model. You can open the device menu either by clicking the interlocking wheel icon or by double-clicking the Spectran V6 Eco tab. In the main menu, you will find the device mode setting, where you can switch the V6 into TX-LO mode for signal generation. Note that the unit must be turned off to change this setting. Once the device is powered on, the device mode field is grayed out and cannot be modified. With TX-LO selected and the unit powered, the V6 is now configured as a transmitter. Next, go to the board config section. In other videos, we discussed using external 10 MHz, PPS, or GPS references to improve the PLL. In this video, we will focus on the signal generator controls. In board config, locate the signal generator settings. The generator type dropdown is initially set to off. Below it, you will find the start frequency and stop frequency fields. Set the start and stop frequencies so they are near the 1 GHz center channel. You can see the center frequency setting at 1 GHz and the current TX output level set to about -30 dBm. This video concentrates on the generator modes themselves. Other device mode options are available but not covered here. If you click TX configuration, the same settings appear in a separate configuration window. To begin, choose Relative Tone from the Generator Type dropdown. To observe the generated signal, make sure a second V6 is connected as the analyzer. Click Start on the analyzer. You will now see a tone transmitted at a defined offset relative to the center frequency, clearly visible in both the spectrum and waterfall displays. Next, change generator type to absolute tone. In this mode, the signal jumps directly to the 1 GHz center channel that is configured on both instruments. Selecting Step allows the generator to step through the spectrum. You can set the start frequency, for example at 1 GHz, and define a step size. The tone will move in discrete steps according to that spacing. Choosing Random Step generates a hopping pattern. The tone appears at random frequency offsets within the defined range. For a continuous sweep, select Sweep. This mode sweeps across the specified frequency range, limited by the hardware bandwidth of the instrument. You can also select Sweep Alternate. This sweeps back and forth between the start and stop frequencies, which shows up as a bidirectional trace in the waterfall. The full sweep mode uses the V6's full hardware bandwidth for the sweep. The actual sweep span depends on the specific V6 Eco hardware model. With center sweep, the signal sweeps around the 1 GHz center channel instead of across the entire possible range. Selecting polytone, also referred to as multitone, generates multiple tones with a defined frequency spacing. These multiple carriers are clearly visible in the spectrum and waterfall displays. You can switch between a center sweep and polytone mode quickly to compare how the signals appear. The relative ditone, sometimes simply called ditone, generates two tones with a specified frequency relationship. This is particularly useful for intermodulation measurements. Finally, the generator can also produce noise. The noise mode outputs an analog-like random noise signal. The digital noise mode produces noise generated by a DSP algorithm. These are the available signal generator settings when configuring the V6 Eco in TX mode. For more information, check out our other videos on our YouTube page or visit eroniausa.com. And if you have ideas for other videos you'd like to see, leave us a comment below.